So we want to welcome all of you to our decoding talk that we're devoting just to alterations, specifically residential HVAC alterations. Thank you for joining us this morning. We are recording this event. We record all of our events, and we take the better of the series and put them on our website to view if you were unable to attend or hopefully not having the technical issues that might prevent you from seeing what we're doing. Our last one we did last month was part of the alteration series also, and we looked at non-residential indoor lighting alteration projects and the code options for those types of projects. We are brought to you by Energy Code ACE. This program is funded by you, the ratepayers of California, so thank you very much. And we are managed through the investor-owned utilities. Specifically, this program is managed by PG&E under the auspices of the California Public Utilities Commission. My name is Gina Rodda, and I am the host of the Decoding Talk series. I come to the table as an energy consultant, started doing actually mechanical energy compliance back in the early 90s, right out of college. So I've been doing these for quite a few code cycles now. Bruce Cheney is my guest speaker, and Bruce, you've been doing this for a while also, haven't you?
Good morning, everyone. Yes, I grew up building houses with my father in Connecticut, so I learned quality control on a job that didn't pay from someone who couldn't fire me. Came out here in the 90s with the Navy, and after 4 years of being forward deployed, settled here in San Diego. Since then, I've gotten to work in all phases of construction with all different types of projects, from condo conversion all the way up to net zero mega mansions, and been working with the Codes and Standards team, helping people navigate and comply with the energy code since 2013. So looking forward to our decoding talk and working with Gina today. Thank you for coming, everybody.
So we have some goals for you today. We're really going to talk through the triggers for different types of residential HVAC projects, discuss which HERS measures are required for those particular scopes of work. One, remodeling might look how we look at local exhaust or our indoor air quality requirements of the code also. So we really are going to be talking heating, ventilating, and air conditioning today. And we're going to talk a little bit about the forms and which forms are needed for which type of work so people can feel comfortable on that. Here's our agenda for the day. One thing we are not including in our time with you today is a break, so I'm hoping all of you are ready for us to go through this content from start to finish with you. We would love to hear from you if you have any questions. We did put all of you guys on mute just to make it go a little bit more streamlined, but do feel free to go into the chat to ask any questions or comments, or raise your hand and we can unmute you if you'd like to speak out loud. So Bruce, you know about Bruce and I. We'd like to know a little bit about who's here in the room with us today. And our first question is, what role do you serve? So what do you do so we can understand how to tailor our content to you? What is your comfort level with residential HVAC change-out requirements? We've had some, they changed quite a bit in the 2013 code is when we saw a big change. It's stayed pretty consistent since then. Oh, yay. I'm so happy. Luis can see the screen now. Thank you, Daryl. And Daryl, have you guys been able to help Diane at all in terms of connecting her audio? So our last question for you, we're going to make sure your typewriter is working. What is the value behind duct testing? Why did the energy code go there? So it looks like we have quite a few plans. Well, we have 5 people, or at least 5 people who are answering my questions here. And we have a building department and an energy consultant. Thank you so much. And you guys aren't feeling really comfortable with residential HVAC changeouts. Well, we hope to fix that. And what is the value behind duct testing? I had one person answer energy savings. Bruce, give us a little update on, why did the energy code go to duct testing? Why is that a mandatory requirement?
Well, they did testing on homes throughout California, and they found out that the average leakage rate was well over 30%. And when you're leaking that much air, depending on where that system is at, you could be leaking it in the attic, or it could be an indoor air quality problem. You could be leaking it on the return side of your system located in a garage. So they determined that having that system sealed up to a percentage based on the vintage of the home, whether it's new construction, then we're down to 5%, or if it's an existing home, up to 15%, that performing that sealing when we're doing work on the air conditioning system is cost effective every single time. That's why it's a mandatory measure. Anytime something is mandatory in the code, it means money that the client is spending today has a definite future economic return. This one's going to be through reduced heating and cooling loads.
Excellent. So let's go back to our presentation. Thank you, everyone. And I'm hoping we've got most of the people connected to us who are going to join us. And, oh, yay, Diane can hear now. Fantastic. I like it when technical issues get dealt with smoothly. So I always like to start a little bit with the why are we having this conversation today, and I want to start with our handouts. So we're really going to be using a series of fact sheets and trigger sheets that are provided through Energy Code ACE. Our very first one here that I'm indicating is just the basics, all the HERS measures, and this lists every single HERS measure that is in the book, shall we say, for residential and non-residential compliance, and really talked about where to find the information about what's going to be tested when we go to those HERS measures. We're also going to be looking at a fact sheet that talks about what is happening for HVAC alterations. So our fact sheets really try and dive a little bit deeper into the topic, use complete sentences, talk about what are the forms that are required, give you links to everything. Then we have quick reference sheets. We have, this quick reference sheet. I use it all the time. You think I'd have these memorized by now, but sometimes I really do need to look these up every now and then. And these are the minimum efficiency requirements of the code. These can be relatively difficult to find because the efficiency ratings for gas furnaces that are, oh, help me here, is it 225,000 BTU? What is the max?
Yes, or less.
Okay, or less. And most AC equipment, 5 tons or less, are regulated through the federal government, Title 20. So they don't show up in Title 24. So these quick reference sheets I find extremely valuable because I can find that equipment efficiency that I could find if I went into Title 20, but I don't want to go into a whole nother code book and find it right there. This is the main thing we are going to be working with today, our HVAC alteration trigger sheet. It's all about alterations. I trigger this and nothing else. So what am I going to trigger in terms of code? Now, if all of you were not able to download the handouts that you had the opportunity to do with the last email we sent you, put your eyes over to the left, you'll see Gina's favorite resources, giving you a direct link to the Energy Code ACE website. The online resource center at the Energy Commission's website, I think, is the best way to navigate their website. We're going to be talking a lot about the HERS providers today, so giving you links to both of those, CalCerts and Cheers. And at the very bottom, you'll see handouts. If you hit this, it will automatically open up a separate browser and download a zip file that includes all of these trigger sheets, fact sheets, and quick reference sheets that I just was talking about. And Daryl, I'm hoping you can help Louise out. I have a feeling he has a bandwidth issue, which is why he just keeps getting the spinning wheel. I really want to start singing a song that starts with spinning wheel, but I will protect all of you and not go there. So when does code apply? Bruce, what code are we talking about, and how do they know their project has to meet this code cycle versus the previous code cycle?
Well, today we're talking about the 2019 code that went into effect January 1, 2020, which, just a second on the fact sheets and the trigger sheets, is a resource. The reason I use them is I have projects spanning 3 different code cycles right now. So anytime somebody asks me an answer off the top of my head, I'll give them the wrong one unless I'm looking at one of those trigger sheets or the actual code book from that code cycle. So currently we're in the 2019 code, January 1, 2020 to December 2022.
they are working on developing the 2022 code right now, and there are quite a few series of online webinars of the Energy Commission trying to get your feedback on this updated code they're writing at this moment. And I encourage all of you to take a look that are interested in seeing what might be coming down the pike. Just last week, they did an overview of what they're proposing for residential HVAC alterations. Reference ACE is my favorite tool that we have at Energy Code ACE. I actually have this hyperlinked right on as a bookmark because I get to it so often. You can download it and use it offline too if getting online is an issue. And it includes the code language itself, all hyperlinked, everything in there. Also the manual. The manual is written to help people understand the code language itself. And then there's also the reference appendices. Bruce, why are the reference appendices so important to our discussion today?
Well, we have to do a lot of testing, and there's procedures that we have to follow to make sure that when we're doing the testing that the results that we're getting comply with the energy code. For instance, when we do a duct test, you want to make sure you take the filter out. So you will follow the step-by-step procedure for how to do the duct test. Anytime there's a question like that, that can always be answered in the reference appendices. Well, if the installer installed the system and the HERS rater is saying it fails and they don't agree with why it fails, well, the tiebreaker there isn't one person's opinion over the other. It's going right to the source, going to the reference appendices. It's the black and white, step-by-step from the Energy Commission of exactly how things are done or who needs to do what to perform the verification or to perform the testing to make sure the way the system's installed, it won't use any more energy than necessary.
So if you haven't checked out Reference ACE yet, I suggest you do so. In fact, I just was looking at it really quickly to help answer Martin's question about space-constrained units. And that is something that is a definition per Title 20 or the federal government. And it usually, well, the equipment is going to be labeled space-constrained. So, you know, just if you are looking at space-constrained equipment, usually I see that associated with portable school buildings for garden-style multifamily in which they're putting the equipment on a little closet on the patio. You'll know when you have space-constrained equipment because it's labeled. It's called space-constrained equipment. Is there a better way of saying that, Bruce?
No. Space constrained, I guess, would be the most common term you're going to see out there for it.
Mm-hmm. So mandatory versus prescriptive and the opportunity to use the performance method. So mandatory measures are, as Bruce said earlier, cost effectiveness had been established for all project types, and mandatory you always have to do. When we talk about mechanical HVAC changeouts, this is going to be that minimum efficiency, which that quick reference sheet is very helpful. Thermostat requirements, HVAC load calculations, 2-inch Merv 13 filters, and these three HERS measures, duct testing, airflow, and fan watt draw. Prescriptively, we have some duct insulation requirements that might be more stringent in some climate zones than the mandatory minimum. So a lot of times prescriptive measures are layered on top of mandatory. And this is also where the HERS refrigerant charge, depending upon your climate zone, lives. Prescriptive measures, you have the ability to do trade-offs for prescriptive measures only when using the performance approach. So Bruce, I find it extremely rare for people to use the performance approach just for an HVAC change-out. How about you?
I agree. On a change-out, it's almost always prescriptive because it's a simple form to fill out to the HERS provider to get the permit. None of the documentation is really required until final inspection. Where we are seeing a lot more performance, though, is in additional dwelling units. Those are becoming very popular, a lot more common. Additional dwelling units are tiny homes. They're going to have a new mechanical system. They're also going to trigger indoor air quality. That's usually where you're seeing performance on the smaller HVAC jobs, but not usually with alterations. Usually in alteration, that's just a prescriptive approach.
And that's when we typically see the CF1R alt for alterations. And anytime we have any HERS measures, that form will need to be registered. So we're really going to talk about when we have HERS measures that are required, because it really does change that documentation process. So let's talk about our 4 challenges with you guys today. We're going to start with I'm just replacing the air handler, or I'm just replacing the AC condenser. Our second challenge is going to be not only are you replacing, but maybe you're also adding equipment, such as you're adding air conditioning to an existing system that does not currently have it. Challenge C, we're going to just talk about indoor air quality and our local exhaust requirements. And Challenge D, things we need to consider when people are doing fuel switching. Fuel switching typically is associated with the home currently uses natural or propane gas, and they would like to fuel switch to use all electric. There are many, many cities that are definitely encouraging fuel switching to all electric, so we'll take a look at that. But let's first start with our most common challenges, which is when a homeowner is replacing their air handler or they're replacing their air conditioner, and this is existing equipment that was there already. So this is going to be just that air handler, and the ducting and any other equipment is going to remain as is. We are not yet talking about also doing something else. So let's just talk about the air handler broke down the day before Thanksgiving, and I need to make sure when my family comes over, I have heat. So we're going to talk through each of these scenarios by first of all defining the scenario. What is it called per the energy code? Then we're going to talk about the trigger per the energy code. And then what are those triggers? And also in terms of the HERS measures that will be required for that very particular scenario, and the forms that will be required for just that scope of work. So let's start with our fact sheet that we have on residential HVAC alterations. In there, there's some, I think they're great simplistic images that talk about the different components of an HVAC system and what is it that we're talking about. So Bruce, what are we talking about when we're saying air handler? What does that typically mean to most people?
Most people are going to be thinking of the gas furnace as the air handler, because when we say air handler, we're talking about the fan that's going to move the air, whether it's over the heat exchanger or over the cooling coil when we're operating in air conditioning mode. But we're talking about the main unit that contains the fan, which is majority of homes in California is a natural gas furnace.
So when we're replacing that air handler, now we go to our trigger sheet. What did I trigger? So we see here on the left-hand side that it's saying, okay, you're replacing this and only this. I'm replacing the air handler unit, which is also considered the furnace if it is a gas system. I have to meet minimum efficiency requirements for that new air handling system. I triggered HERS duct testing. I don't care how much ducts you have. I don't care you didn't touch the ducts. Because you replaced the air handler, you have triggered HERS duct testing. But you see that nothing else along this row here of all of these requirements is indicating a yes. So let's talk through equipment efficiency. So this is when we're going to take a look at that quick reference sheet that we have on efficiency. There we go. It's just moving a little slow. And let's take a look at what is specific to our air handler on this quick reference. Here we see weatherized versus non-weatherized. Bruce, what's the difference between weatherized and non-weatherized?
The minimum AFUE for that outdoor unit, because weatherized, there's usually some insulation, some additional material that goes into it. That has to be an 81% efficient unit. If it's an indoor unit, standard furnace, going to be located in the garage or attic, that only has to be 80% AFUE.
And I highlighted the ones that were all about natural gas or propane gas versus oil. California, really, I don't know any places that use oil. Do you, Bruce?
I don't know any place that uses oil, no.
So now let's dive in and look at what is this HERS measure. So this is now we're looking at the resource that was in your handout as just the HERS measures. So here for duct testing, it is telling us it's a mandatory requirement and gives us the code section And in case you guys don't know this about our resources, everything is hyperlinked. So if you're looking at the PDF and you hit that code section, it will take you straight to that code section in the 2019 reference ACE. So that's one of the things that's so great to use many of our resources online because they all speak to each other. And then you'll also see that we provide the reference appendices code section. Again, it's a hyperlink, so it will take you straight to that section in reference appendices. And this is what it's going to look like. So Bruce, can you walk us through what a HERS rater is going to do in terms of that duct testing because I changed out the air handler?
Yeah, so depending on the scope of work is going to trigger the level of duct leakage testing. Now, the one key thing I want to point out here, especially when we look at the reference appendices, is we have the verification description of whether we're doing the testing, whether it's an altered existing system or a new system. But the user application there, notice the first user application is the installer. When we're performing duct leakage testing, the installing contractor is supposed to have the same equipment as the HERS rater and perform the duct leakage testing prior to the HERS rater. When the HERS rater shows up, the HERS rater verifies that duct leakage by repeating the testing. And that's why it's nice that we list the reference appendices procedures over there on the right-hand side. So the first step is always going to be they're going to use a duct blaster and do a fan pressurization of the duct leakage system to determine what the total duct leakage is. If it's a new system, they're going to fall under 5%. If it's an existing system, they're going to be allowed up to 15%. If they don't pass either of those tests, then we can bring in the blower door, pressurize the entire building, and do a duct leakage to outside test. Depending on whether it's single family or multifamily, we'll have a 10 or 12% leakage number there. If most of the ducts are inside conditioned space and they have a decent envelope, then a lot of homes will pass that test. A lot of homes, however, don't have the ducts located inside conditioned space. A majority of homes in California have those ducts located up in the attic. When we run into that situation and they can't pass the duct leakage test, all hope is not lost, especially installers,
You're
contractors.
still going to be doing
if you've
some
never
work.
done this before, yes, you still have some additional steps to take. We don't just wash our hands of it and walk away. But we don't just say the home fails either and that you can't close out the permit. What will happen is the HERS rater will bring a fog machine. They'll start up the duct blaster. They'll introduce the fog into the pressurized system, and the HERS rater and the contractor will visually verify all the accessible portions of that duct system. As long as fog is not coming out of anything that is accessible, then the HERS rater is allowed to sign off on that system saying, hey, parts of the home are inaccessible. Wouldn't be economically feasible to rip out drywall, tear the house apart to chase down 10 or 20 CFM. So they've sealed up everything that they can touch, and it's called pass-by fog. So we'll talk through this with the other HERS verifications as well, but there is never going to be a situation or a home that you're going to run into that can't have the permit closed out, that there isn't some way to test it, or there isn't some way to document that every best effort has been performed and show that the home does comply with the energy code and the permit can be closed. So in other words, installing contractors, don't think that you're buying all the problems in these existing homes. There's compliance options for every home. We want people to comply with the energy code, not run away from it.
I like to call it, I did the best we could. We did the best we could. And Bruce
Yes.
talked just briefly also about what happens, what are the goals of the testing, but talk to us a little bit about asbestos and existing homes and what's going on with garages, Bruce.
Well, if we have a system with asbestos, then that system is going to be exempted from testing. We don't ever want to disturb asbestos or cause friable asbestos to become airborne for the performance of energy testing. If we have ducts in a garage, though, we have an additional consideration, especially for existing homes. What happens is even on an existing home with an altered system is your duct leakage allowance drops down from 15% down to 6%. What also has to happen on every one of those is the HERS rater is going to bring in a fog machine, and you're going to fog that system while it's pressurized and verify that those ducts in the garage do not leak, especially the return side of that system. So if you have ducts in the garage, you don't have that 15% allowance, you're going to be held to a tighter duct leakage criteria, and you're probably going to be fogging almost every single one of those to verify if there is any leakage that it is not occurring in the garage. So keep that in mind. A lot of these that I see are on platforms or old drywall and 2x4 platforms. You're going to basically have to disassemble a lot of those and crawl underneath those and build a duct system or a plenum in there to be able to get those systems to comply. So systems are homes with systems in the garage. We want to make sure that health and safety that we're addressing, that we can't introduce any contaminants into the HVAC system from the garage through the duct system.
And that is a brand new requirement to the 2019 code. So far, that is the only thing that's different than anything that was required in the previous code cycle. This 2019 code cycle had a lot of new stuff about indoor air quality, and that was a pretty big one. Forms. As I said earlier, we're pretty much going to just be talking about the CF1R alt form. So if they are changing out their air handler, the CF1R alt form is going to be required. And yes, duct testing had been triggered, so it does need to be a registered CF1R for it to be valid for this type of project. Now we have CF2Rs and CF3Rs. CF2Rs are forms that are to be provided by the contractor about what they did out in the field, and the CF3Rs are by the HERS rater about what they verified. Bruce, talk to us about the CF2R MECO 1 and a little bit about the flavors about how we have all these different mechanical forms for all these different HERS verification measures.
Well, the MECO 1 is a form we're going to get for every single mechanical job, because what that does is it lists all the mandatory measures for the project, and it lists all the system information. So it'll have the model number, the serial number of what was installed, the efficiency. If it's a registered CF2R from one of the HERS providers, they typically also list what was required from the CF1R alt or from a CF1R perf. So for the building inspector out in the field, that is going to be your primary document that you're going to use for your inspection to compare what did they actually install versus what was required, because that document is going to list everything there for you. The other document we're going to see on virtually every job, any job that's a ducted system anyways, is that CF2R MEC 20. Now notice this is a contractor document at CF2R, that the contractor, the way that the code works and the way that it's written, is the contractor pulls that CF1R when they get a permit. The contractor performs duct leakage and documents it on the CF2R. And this is really important because this is the only way that sampling can happen. If they're doing sampling, then the contractor has to perform the duct leakage testing and enter the information into the HERS database so that that HERS rater can pick which systems they're going to sample from and perform the verifications on. So the first forms they're always going to have are a registered CF2R MECO 1, and then that CF2R MEC 20 for that duct leakage testing.
So Bruce was talking a little bit about some of the great stuff that's available when these forms are registered. So the CalCerts website, www.calcerts.com, has different ways that you can utilize the website. And we really do want to emphasize the project status report. I think this is something that most people are aware of right now. Bruce, what is the project status report, and why do we think it's one of the best tools the inspector has?
Well, I like to make the analogy of the energy code is like pushing a string. That when you change something and you push a string, you can't predict exactly where that string is going to bend or which way it's going to push. And that's why it's nice to have these project status reports. What they do is once the information's been entered into either one of the HERS providers, either CalCerts or Cheers, they will generate this project status report that lists the registered CF1R, and then it lists which installation certificates and which HERS verifications are required. It does not list all of the HERS verifications or all the installation forms from the code. It only lists the forms specific to this project that are triggered. So we call it the building inspector's best friend. Really, it should be the contractor and the HERS rater's best friend as well, to keep them both in tune with what phase are we at as far as this project, what forms need to be filled out next, when do we need to call for inspection. This becomes really important on these new construction projects, depending on where those ducts are located and what duct leakage testing is triggered. If they close up stuff in interstitial space and duct leakage is required, you may not be able to seal up those leaks if they're up there in between the floors. So project status reports are a great tool to keep everybody in line with the project as far as what's required, what's been done, what still needs to be done. I teach a lot of the building inspector classes, and we teach in the building inspector classes that the building inspectors are to log on to the HERS providers and download these. And if the report is not all green, then the home is not ready to be inspected. So I would strongly suggest, if you're not familiar with these project status reports, if you haven't seen them before, to get familiar with the HERS providers, log on, navigate through, go to some of your old projects, look at the project status reports, and be aware of them for your future use.
So all of them have QR codes, so that really helps too if you can get your hands on one. I know a lot of building departments that require the contractor go in and give them a copy of the project status report with everything showing that everything is good to go before they'll go out for final. Or we have building departments that go in themselves into these databases and verify what's going on with the project. So we wanted to kind of show you how easy it is to get in here. So you do need to have your own password and username, so you do need to sign up for these websites. And getting that CF2R here with CalCerts, they have all of these, are these, what are those shapes? Bruce, I always mix up the hexagon versus octagon. 2, 3, 4.
Oh, because you said it, now I'm going to mix it up. I believe that's a hexagon.
And you'll see there's one just for CF1R, one for CF2Rs, et cetera. They help you navigate directly to where those forms live. And Bruce, right here, it even tells you, it helps you with where are things, where do we find things here in the CalCerts website?
Yes, and also the next step of what needs to be done, and then the status of all the documents is listed there. So, for example, if we're going out to a job, or we're about to drive out to a project that we need to inspect, and we log in and we see that all the CF2Rs say report results, probably means that job is not really ready for the inspection if none of the testing's been done and none of the data has actually been entered into the HERS provider database. The really important thing here, though, is that to understand that the forms that we're always looking at as far as inspectors or field people, that the forms don't actually exist until the information's been entered here into the HERS databases. And you have to have the login credentials to be able to access the information that's been put into the databases. Both the installing contractor and the HERS rater also need to have login credentials to be able to access this information. We can see on this one project that we've got down here that the lighting installation certificate has been done. And we can see that the document author was Hugo, and the responsible person that signed it was the builder. So contractor needs to have access to this, building departments should have access to this database. And I don't know if we mentioned this, Gina, but this is all free. It doesn't cost anything to do any of this, to access these, to see this information, or to enter the information in the database. They do charge you $1 for the contractor. Basically, that's a form of verification that you're actually logged in and the one entering the data in there. But the fees and everything are nominal. There's no cost prohibitions against people using this database, and it's free for the building departments.
And that is also the case for Cheers. So Cheers is the other provider out there, www.cheers.org, and they do also have a project status report. And you'll notice it has that QR code, and it has, hey, green means it's been completed, and there are no reds here. So this is actually a project status report in which everything is complete and ready to go for final. And things look a little bit different in the Cheers website, but honestly, I find that both of them are pretty easy to navigate once you've done it once. Here, instead of those hexagons, you'll have where they break it out by building feature and which forms are applicable for that particular building feature. And Cheers, along with CalCerts, does fully support people coming in and using these databases if you are involved with the project. So you do need to sign up. They're easy to navigate. We encourage everyone to give those a try if you haven't seen them. Now let's talk about replacing the air conditioner. We talked about the air handler. Now let's move outside, which is typical for a split DX system, and talk about replacing that air conditioner. And that air conditioner is going to be one that was there already. So this is all about an alteration, not the fact that we're adding it. And John is asking a question, will the information be on both of the websites? John, no, it won't. And that's why it's important to look on all of the registered documents. It always says which HERS provider was used for that particular project, and that's what's going to help dictate which database are you going to go to based on which registry was used. But there's no automatic process that automatically puts a project into one because you used the other. So that's the only thing we really need to be looking at those forms to see where was it registered. So when I'm replacing the air conditioner, you see that the thermostat, suddenly we see yes under thermostat, and that's very, I think, unique myself, that thermostats really go into play when we're talking about air conditioning. You'll see that duct leakage. I don't care that you didn't do anything to the ducts. All you're doing is replacing the air conditioner. You triggered duct leakage. And refrigerant charge. Now this is going to, I'm sorry, this is a HERS verified airflow, which is tied to refrigerant charge, which is dependent upon your climate zone. So this is only going to be something we are going to concern ourselves with because code requires it in climate zone 2 and 8 through 15. Now I personally think refrigerant charge is vitally important, and even though I'm in climate zone 3, I as a homeowner would want it done anyway. I don't know about you, Bruce, but I think that refrigerant charge is just so important to the efficiency of a system.
Well, the fact that many contractors don't even own digital gauges or thermocouples or ways to measure how much refrigerant is in the system just goes to show, you know, how mandatory that really should be. That somebody should be required to hook up a set of gauges and measure and see where's the system at least once in its life cycle.
So let's dive in a little bit regarding thermostat. So this is on that residential HVAC alteration fact sheet that tells us about what does that thermostat, how does it need to be programmed as. A lot of people hate programmable thermostats because people don't program them at all. It doesn't work so great. But it's all about having four different settings per day. You get up in the morning, you go to work, you get home from work, you go to bed. And potentially all those 4 times you might have the thermostat set to different temperatures in the home. It also has to have a separate setting for holidays also. So a setback thermostat has been something that's been required, gosh, I can't even remember when it first came into play. I want to say the 2005 code. But when we need to make sure our thermostat is a setback thermostat is when we're putting in air conditioning or changing our air conditioning system, which I find is so interesting that it's not something that is a requirement when you're changing out that air handler. So we have our minimum efficiencies here, and in the last code cycle we saw this breakdown in terms of different EER ratings versus SEER ratings. Bruce, why do we now have EER ratings in addition to SEER ratings as of the 2016 code cycle?
Well, energy efficiency ratings are really a much better indication of how efficient that unit is and how much energy it's going to use. The SEER, seasonally adjusted energy efficiency ratio, it's not as good of a metric for measuring the total energy usage of that unit. So when they upped the 14 for the southwestern region of the United States and the Department of Energy increased the minimum SEER rating for us to 14 SEER, they also added in that requirement for EER, so we're getting an overall system performance efficiency, not just a seasonally adjusted one.
So just a little bit fine-tuned. It also really matters the indoor-outdoor unit systems, their efficiency changes depending upon which is being used for indoors for outdoors. So that's part of what that HERS rater is looking for too, is potentially that pairing regarding efficiency, and I jumped ahead of myself. Forget I just said that because we're going to talk about that a little bit later. So we already talked through duct sealing. Now we have airflow, cooling system airflow, and refrigerant charge. So Bruce, again, could you walk us through what's going on when we're verifying airflow?
Airflow has to physically be measured, so we're showing probably the two most common methods here. One is a flow hood, which you can do if the return is smaller than the flow capture hood. You're not allowed to tape off the return if it is larger than the flow capture hood. Usually when we run into that, then we use the second picture you're seeing there, which is the flow grids. The third method would be the plenum pressure matching method using the duct blaster. But it's something that requires an actual physical measurement. It's not something that can be done with temperature split or spot radiometer temperature split or the old calibrated sweaty hand. It's something that physically has to actually be measured. The reason we're measuring for an altered system is we're making sure that there's a minimum amount of airflow across that coil so that when we're performing the refrigerant charge that we're somewhere near what the manufacturer specs are for airflow across that coil when the refrigerant's flowing through it. Now, of course, most people are going to say, well, what about these existing homes? We're altering the systems. I'm adding air conditioning to this home, or the duct system was never properly designed. Why do I have to own the previous contractor or the previous code's problems? You don't have to. If they don't pass the airflow test, we have to take some remedial steps. We'll make sure all the registers are open and that the air filter is installed for the airflow test. We're doing something like the flow hood. The filter comes out for the duct test, but we don't do the airflow test in an unnatural situation. In other words, the airflow test has to be done the same way that the homeowner is going to be using the system with the filters and everything installed. Turn the fan on. We want to make sure everything is in high speed, so that's typically going to be in cooling mode. For older systems, we may have to check the fan speed setting, make sure that it is on the fastest fan speed, and that the airflow is always going to be measured through the returns. The airflow is never measured through the supply grills. We can't say, oh, I didn't get it through the return. If I just go add up all the supplies and that equals it, can I say that that was my airflow? No, it must be the airflow through the return, through the system. Now, if we don't pass the airflow test after doing all that, and remember, when we're doing this for refrigerant charge, it's not 400 CFM, which is industry standard. It's not 350 CFM per ton like would be required for a new installation. It's only 300 CFM per ton. So if we've done all this and we still can't get to 300 CFM per ton, we take the remedial actions. The remedial actions are we make sure that the filter's clean. We don't want to use a construction filter, the one that was in there during construction when they were drywalling and the air conditioned drywallers wanted to be cool, so they ran the system with all the dust in there. Make sure we've got a clean filter, that all the registers, dampers, everything's are open. Remember, the duct systems usually go in pretty early on. Then the low voltage guys, the telephone people, the security, everybody else comes through. And those big R8 ducts are great knee pads. So go check the ducts, look where other people crawled through stuff or set things on it, make sure that nothing's been flattened out. Check the evaporator coil. Not too long ago, we had a system, brand new installation. We tested everything. The watt draw on the fan was high. We couldn't figure out why we couldn't get the airflow through the system. Actually ended up taking the evaporator coil, the furnace out, looking at the evaporator coil. There wasn't one. There was two installation labels that were inside the flex ducts that got sucked all the way through the fan, through the system, and were stuck to the evaporator coil. So make sure the evaporator coil hasn't got something stuck to it. Again, check that fan speed setting. And then check the return grill. Do they have enough return grill area? If all those steps have been performed and they still don't pass the airflow test, then the HERS rater can sign off on a system that still doesn't meet the airflow. Obviously not the best thing for the homeowner who want to do everything possible, get the airflow up so the system's close to the manufacturer specifications, but remember, there is no home that's going to not comply with the energy code. There's always options, even if they're not good ones.
Refrigerant charge. So there are 3 different ways to go about refrigerant charge. And remember, refrigerant charge is a prescriptive requirement in certain climate zones, climates 2 and 8 through 15. Pretty much when you're doing just an HVAC alterations, there's no wiggle room at all with that refrigerant charge. If they were doing other work with the home, such as an addition or major overhaul of their entire home, they might use the performance approach and they can then trade it away at a penalty, but I find that extremely rare. And we can do either standard charge or weigh-in charge. I'm not going to talk about charge indicator display because that doesn't exist yet. We keep wanting it to exist. We call it the sparkly unicorn. And maybe someday soon we keep hearing that there's some product out there that might be able to meet all of those requirements, but that's it. We're not going to talk anymore about charge indicator displays. Bruce, what's the difference between standard and weigh-in, and when might I be using one over the other?
Well, standard systems, standard direct expansion air conditioning systems have a set of ports on the condenser outside that you can hook up a refrigerant gauge to, hook up some thermocouples, and then the manufacturer will have a stated subcooling that you're going to measure with your gauges. When we get to mini splits, when we have a single condenser and multiple head units, multiple evaporator units indoors, those units don't have the same connections. They can't be measured in the same way. They have to be charged to the manufacturer specifications for an amount of refrigerant based on the condenser capacity, those evaporators, and the line set lengths between the condenser and the evaporators. Well, those are not exempt from refrigerant charge verification. They are exempt from the airflow fan lot draw and duct leakage because they're not ducted systems, but they are not exempt from the refrigerant charge if they're in one of those climate zones. So what has to happen ideally is that the contractor coordinates with the HERS rater to witness them weighing in the refrigerant charge. This also happens when it is cold outside. Someone's furnace gets changed out in the wintertime. They have air conditioning and they have it changed out as well. Well, one of the properties of these systems is the refrigerant contains the lubricant, and until that system gets to a certain temperature, they won't separate. So it's not good for the system to run it when it is cold outside. So if the air conditioning system is changed out in the wintertime, that also would apply that the weigh-in method could be used. Now, the weigh-in method requires that the HERS rater is standing there with the contractor as they follow the manufacturer's instructions for adding the required amount of refrigerant based on the manufacturer's specifications. If the contractor starts up that mini split system without the HERS rater there, and then they need to perform the HERS verification, the contractor is going to have to bring a vacuum pump, an evacuation tank. They're going to have to basically pull that system down dry, put a vacuum on it, put the micron gauge on there, and then keep it dry with a vacuum pulled for whatever the manufacturer specifies. And the installer and the HERS rater are going to have to stand there the entire time, whether it's 30 minutes, 45 minutes, 4 hours, and then witness the system properly charged. So keep in mind that systems are not exempt, that even the ductless variable capacity mini splits have to have HERS verification, but the way that the HERS verification is performed is drastically different than what most contractors installing standard split direct expansion systems are used to. So it's not saying it can't be done, it's just a big difference in how it's done, and be aware that when it is cold outside, the refrigerant charge should not be done.
So forms. That same CF1R alt is going to apply to this scenario, and yes, it does need to be registered. And we have quite a few more CF2Rs and 3Rs now, because now we have their very own form for airflow in addition to duct testing, and refrigerant charge also has its very own form. So now that we've kind of gone through this first challenge, this is our beefiest challenge with you guys, let's do a check your understanding. We have some questions for you. So I know this image seems a little blurry. Hopefully you guys can read it. Which scope of work requires duct testing? Do you need duct testing when you replace the air handler? Do you need duct testing when you replace the AC condenser? Do you need duct testing when you replace both the air handler and the AC condenser? Excellent. We need duct testing, period, every single time. You need duct testing when you replace the air handler. You need duct testing when you replace the AC condenser. You need duct testing when you replace both the AC handler and the AC condenser. This is one of those in which every single one of these is the right answer. Let's go on to our next question. Which scope of work requires HERS refrigerant charge testing? When I'm just replacing the air handler, when I'm replacing the AC condenser, when I'm replacing both the air handler and the AC condenser? Excellent. You guys are getting this. Yeah, I'm going to be needing that refrigerant charge when I'm doing anything with the AC condenser. So if I'm just touching the AC condenser or I'm doing the air handler and the AC condenser, refrigerant charge, depending upon my climate zone, is going to be required. And I have one last question for you. Which scope of work is going to require a programmable thermostat has been verified as being provided or is in place?
It's programmable with your finger.
I love stickies. I think stickies are the best thing ever. But I'm not sure a sticky is going to do the work of the programmable thermostat in this situation. Okay, guys, this one's a little weird. If we even look at our trigger sheet here, if we look at the replacing the refrigerant containing, replace any refrigerant containing system component, that's where we see the thermostat as yes. We don't see the thermostat as yes when it's just the air handler being replaced. Now, if you, in replacing the air handler, you had to disturb the refrigerant, well then yes, then it might be in play, and then depending upon your climate zone, you might have to do that refrigerant charge because you disturbed the refrigerant. But it's really honestly tied to when we're doing any work with the AC condenser. Excellent. Let's go back to our presentation and start talking about when we're doing more than just the indoor unit and more than just the outdoor unit. So our first thing we're going to be taking a look at here is what happens when we are going to also be doing something with ducting and or we want to add air conditioning to an existing system. So the first scenario we're going to look at is we're replacing the ducting only. Everything else remains as is. So one thing to look at is when the Energy Commission considers, or the Energy Code considers a new replacement system. So a new replacement system in terms of ducting is when you're replacing more than 75% or more of the linear length of duct. It's not 100%, it's 75%. So it's basically you're replacing the majority of the duct system, but you're probably not doing the boots and other places that are potentially inaccessible. But did you do 75% or more, of which then we have triggered a lot of requirements in terms of our HERS measures. And I think it's just pretty much just HERS measures, oh, and the air filter. So when I say replace all, I mean replacing 75% or more of the linear length of ducting associated with the system. I've triggered HERS duct testing. There's that lovely duct testing again. I've also triggered air filter requirements and then the HERS verified airflow fan efficacy if I have air conditioning. In addition to the fact that now I need to meet my prescriptive duct insulation requirements associated with the code. So we've already talked through duct sealing, airflow with you. Let's talk a little bit about air filters now. So there's some big changes that happened with air filters with this code cycle. Bruce, walk everyone through what's going on.
Well, with the jump to comply with ASHRAE 622, one of those things is that we're going to have Merv 13 filters now. With the Merv 13 filter, we also are going to have a minimum 2-inch filter slot to be able to accommodate. That filter is going to be more restrictive to do more filtering. It's going to require that 2-inch filter slot so we can hopefully get a pleated filter or something like that, something that increases the surface area of the filter so we don't have as big of an energy penalty to pull air through that more restricted filter. So one of the things the HERS rater has to verify when they're performing any testing now is that any system that has more than 10 feet of ductwork has that minimum MERV 13 filter, and in addition to that MERV 13 filter, the 2-inch filter slot.
I do want to point out what we consider a ducted system is when the ductwork exceeds 10 linear feet. There are some systems where they have like one little hub of ducting. If it's less than 10 linear feet, then the air filter requirements do not apply because that's not considered a ducted system. A lot of people confuse that with 40 linear feet, which is a wholly different thing that we'll talk about a little bit later. But do be aware of what we consider the ducted system. And when we talk about filtration, what needs to be filtered, Bruce?
All of the air. If outdoor air is being brought in, then it needs to be able to pass through that filter. Any air that's going to go through the space conditioning system. Basically, if the humans occupy that space, the air needs to be run through a Merv 13 filter in that space for the occupants. The other issue with this is that we have to have a system design that, since we're putting this more restrictive filter in there, that it's going to be designed and sized properly as far as the return grills and the ducts to allow the fan system not to use more energy than necessary.
So there's all sorts of different configurations. Oops, sorry about that. Bruce, you and I were both playing with the buttons. You've seen so many different things out there, even in the last few months of which this was in play. So what is it we want everyone here to walk away with truly understanding with these new MERV 13 filter requirements?
Well, that there is the MERV 13 requirement, and then there's the requirement to have the 2-inch filter slot. Now, don't get me wrong, the code still allows a 1-inch filter, but if you're going to do a 1-inch filter with that MERV 13, there's an additional document you have to provide, a calculation showing that the face velocity of the air is not going to exceed 150 feet per minute across that filter. In other words, the air is going slow enough that the filter has time to grab onto stuff in the air. The first couple of homes that I ran into when I did HERS testing at the beginning of this year, little small systems would have required basically 10 square feet of filter area to comply with that 1-inch filter, and they only had about 5. So you'd have to basically double the size of most furnaces, the foot of the furnace where the filter is going to sit to be able to accommodate that 1-inch filter. The other thing that I have been seeing is I do get the 2-inch filter slot, but I don't get the MERV 13 filter. I get like 2 MERV 8s. Well, 2 MERV 8s is MERV 16, right? So that's better than MERV 13. Or the other thing I keep getting a lot of is that they're putting in a 4-inch filter, but then only a MERV 8 filter in the 4-inch filter. So we have to meet both of those requirements. It has to be the 2-inch filter slot and 1 MERV 13 filter. Now, that's a definite big no-no for those of you that don't do this all the time, never measure the stuff, that you're doubling the static pressure through the return of that system by putting 2 filters in there because it's only meant for 1 filter.
Reminds me when you try and blow up a balloon, and for some reason you just keep blowing as hard as you can, but the stupid balloon won't blow up. Fan efficacy. So we had some changes. Oops, sorry. Yes, Bruce?
Nope, you go ahead.
Okay, so fan efficacy, we had some new changes to the requirements regarding fan efficacy, but tied to the federal government requirements of efficiency of gas furnaces. Bruce, talk us through what this is all about, and what does that mean to my fan efficacy testing?
So this actually changed before our code went into effect. So our 2019 code went into effect January of 2020. This was put into effect by the Department of Energy back in July of 2019. So any gas furnace manufactured after July 3, 2019 has to show a fan efficacy of less than 0.45 watts per CFM of air. This is only for gas furnaces. So let's say that you have a heat pump. If you have a heat pump, you have an air handler. That air handler is allowed 0.58 watts per CFM of air moved. However, if it's a gas furnace, you're only allowed 0.45 watts. Now, this should hopefully be making a couple light bulbs go off or question marks in people's heads that, hey, Bruce, you just got done talking about not putting in 2 MERV 8 filters and a MERV 13 filter and a 2-inch filter slot. Yes, they have a more restrictive filter, and if they're using a gas furnace, they have less wattage to work with to move air through that filter. So this means that that system design, as far as being able to accommodate, if you're not using a heat pump, if you're using a gas furnace, making sure that you properly design the return, or if it's an existing home where you're having to modify it and you're going to have to comply with this, that you have a way to modify that existing home or to add an additional return so that you can comply with that lower watt draw. Because again, if it's manufactured after July 2019, it's 0.45 watts per CFM. We're into, September 2020? I haven't seen a unit manufactured before July since back in around August of last year. So pretty much everything you see now for a gas furnace should be 0.45 watts per CFM.
Unless someone has a stash somewhere in some closet. Now, we've been talking about return grill. Now, when we're talking about fan efficacy, there's actually two pathways. You can either use these tables, saying this is like the prescriptive pathway. I do this, I don't have to do anything else in terms of verification testing. But I really want you to look at this. And what's the standard size air conditioner do you typically see in the 2,500 square foot home these days, Bruce?
2,500 square foot home, you would probably see at least one 5-ton or maybe 2 3-tons usually.
So let's look at our charts, and we'll see on table B, 150.0B, we can't even use this chart because it maxes out at 2.5 tons. So we go down to the next table, which it's labeled return duct sizing for multiple return duct systems. And here we see our 3 or 4-ton systems. And look at how much that surface filter grill is. That's pretty humongous. I like to call these the gargantuan return grill tables. Why is the bigger the return grill, the better the energy performance, Bruce?
Because we're giving the filter more surface area. So we have to pull the same amount of air through a larger surface area. That means there's less restriction against that air for the volume of air that we need to move. So the larger the filter grill, the greater the airflow or the less restricted the airflow is going to be.
So Bruce and I like to use these tables as a, hey, architects, are you making sure you've designed in enough area and really thinking about return grill sizing and where is it going to go? But then also to our HVAC contractors out there that usually they look at these tables and they're like, no, I've never installed anything that had return grills this big. Well, that could be part of the reason. Honestly,
as a HERS reader, that's where I use it the most is when the system doesn't pass the airflow test.
Right.
Exactly. I usually break out table 150 here and I say, let's compare what you did against what we would have to do to comply prescriptively. And yeah, usually that 5-ton system's falling down in the 1-ton single return table and you're like, I think I see some of the problem.
Again, a registered CF1 or alt form is what's going to be used for this type of project. And we have even more CF2 and CF3R forms as we have more and more HERS measures. And you'll see that there's alternative paperwork for when you're doing the verified fan efficacy airflow versus doing the return grill using those prescriptive tables. So there's so much paperwork choices depending upon which way we're going. Adding more than 40 linear feet of ducting. I find that a lot of people confuse this 40 linear feet with a lot of other things. So remember, a ducted system is the minute I have more than 10 linear feet of ducting. I'm not saying, and this is adding 40 linear feet of ducting, not altering less than 40 feet of ducting, adding. So sometimes I'll have people go, but Gina, I'm only altering 15 linear feet of ducting. Yeah, you triggered duct testing because this exception they have written into code is all about adding to an existing system. It has nothing to do with altering what's there already. So I'm adding to an existing system. By adding more than 40 linear feet of ducting, you'll see that load calculations are required in addition to that duct testing, and that those new ducts do need to meet the mandatory and prescriptive insulation requirements. Let's talk a little bit about load calculations. So you've heard Bruce and I kind of really hammering away here about how if we're not designing these systems, they are not testing out. And if we're not making sure that we're designing these systems to what the code requires, right, Bruce? The code requires that load calculations be done, especially when we're adding additional conditioned floor area to an existing system. What else do we need to consider?
Well, down by me, the thing that I see a lot of is heat-only systems or air conditioning being added to a heat-only system in an existing furnace that may be 1, 2, 5, 10 years old. Because down here in San Diego, furnaces die of old age, not of use. They don't get used a lot. So the air conditioning gets changed out more than the the air conditioning gets changed out more than the furnace does. Well, there's other considerations for that furnace, especially concerning the temperature rise. There's a mandatory requirement in Part 6 that the installing contractor verifies the furnace, when it is installed, does not exceed the manufacturer's inlet-to-outlet temperature rise specification. In other words, making sure that the airflow is set properly when that system's running in heating-only mode. That's not something that is HERS verified, but it is a mandatory measure in the code that the installing contractor is supposed to make sure that the system complies. So there's additional things that go beyond our energy efficiency here that are health and safety, that are tied to the equipment loads, performing load calculations, and then making sure the equipment is sized properly. If they're grossly oversizing the equipment, then you have things like short cycling, which air conditioning is going to cause huge amount of energy usage, excess energy usage, and if it's short cycling in heating mode in a gas furnace, you're going to be cycling that heat exchanger through hot and cold, and you could cause stress fractures in it. Something we definitely don't want to do, not for the sake of energy efficiency anyways.
There's so much of the energy code that is health and safety concerns. It ain't even funny. I've done a lot of people, we don't have time for the energy code. Well, you know, there's a lot of health and safety written into the energy code. So here for our HERS measures, our duct testing associated with those ducts when they're over 40 linear feet of new ducting to an existing system. We have those same CF2Rs that we talked about before that are verified with the HERS rater CF3Rs. So now let's talk about the ducting is being replaced and the HVAC system is being replaced. It's the whole shebang. So we're not talking about some of that system staying, and we're not talking about going ductless. We'll talk about that in just a little bit. So this is the entire system, more than 75% or more of the ducting, the indoor unit, and the outdoor unit. Well, hopefully you won't be surprised that now we probably triggered almost everything associated with HVAC systems in the energy code. We have that equipment efficiency, those thermostats, the load calculations, duct testing, the air filter requirements, airflow and fan efficacy, and the prescriptive duct insulation and HERS verified refrigerant charge depending upon your climate zone. So we've talked through a lot of these. What we haven't talked through yet is when we're doing something extra credit. There is the ability to take extra credit for higher efficiency equipment than that mandatory minimum set by the federal government in a performance calculation only. So if a performance calculation is used, people get credit for higher efficiency because they're trading it most likely towards wanting more windows or wanting some flexibility on insulation. So do be aware there are a lot more HERS measures out there that we're not talking about too much today because they're not most likely paired with just an HVAC system alteration. That same registered CF1R alt form is what we're talking about here when we're talking about when we're replacing 75% or more of the ducting and the indoor and outdoor unit. Now that we've gone through what happens when ducts are involved, let's do a check your understanding. So my first question for you, which HERS measures are required when replacing 10 linear feet of ducting in climate zone 12?
I think it's 100.
Oh, sorry, 100. 2 zeros. I purposely tried to be really far away from 10 linear feet. When you're replacing 100 linear feet of ducting in an existing system, which HERS measures are now required? And there's still about 200 linear feet of ducting remaining as is. So I'm not replacing the entire ducted system. I'm replacing a big chunk of that system. Excellent, everyone. You've definitely triggered the duct testing. You don't trigger the air handling fan efficacy. That's only triggered when doing all of the ducting. But we definitely triggered duct sealing associated with that addition of new ducting or replacing some of the ducting, not all of the ducting. Let's go on to our next question. What is the maximum fan watt draw for this completely new system that is involving a gas furnace, an air conditioner, and all new ducting? Excellent. Everyone's got this one, Bruce. Fantastic. That's that 0.45 watts per CFM, because this is a unit that has been manufactured after July 3rd of last year. And we have one last question for you. Which HERS measures are required when replacing everything in Climate Zone 12? Excellent, everyone. You guys are getting this. Every single one of these is going to be required in Climate Zone 12 because refrigerant charge is prescriptively required there. And when I am replacing the ducting and the air handler unit, I definitely have my the air filter. Because I have air conditioning, I also then have airflow and fan efficacy. And that duct sealing happened well because I replaced and did anything with that ducting, honestly. Okay, let's go back to our presentation. And what we'd like to talk about now with you is indoor air quality. And I got to tell you guys, if you didn't think Bruce was passionate on what we previously talked about, well, this is something that Bruce really holds near and dear to his heart. What are we doing to make sure the homes are safe in terms of indoor air quality? And Bruce, I don't know about you, but I have had many of my architects and many of my homeowners contact me in the last few months going, what can I do to make my home safer with the COVID crisis that's been going on? Have you been getting those phone calls?
Yes, I've also seen lots of snake oil things being recommended to homeowners and on Facebook and various other channels, so making sure they understand it's very simple to do indoor air quality. It's not, some of the map looks scary, but really the software does that for us, and so does the forms. It's not a very hard thing to accomplish.
I got to tell you, the Energy Code has incorporated some pretty aggressive indoor air quality requirements. We saw that with the Merv 13 filters for our HVAC systems. So let's start talking about local exhaust. That is bathroom, kitchen exhaust, and clothes dryers when we have them being exhausted to the outside. Now, what we've done in Title 24 Part 6 is incorporated a standard that already exists out there, and that's ASHRAE 62.2. What's also new to this code cycle is ASHRAE 62.2 will apply to multifamily dwelling units. I don't care if they're high-rise, low-rise, etc., in addition to single-family homes. So these are requirements across the board for residential dwelling units. And that local exhaust is, as defined by ASHRAE 62.2, mechanical exhaust system shall be installed in each kitchen and each bathroom. There are some things we need to consider when it's a non-enclosed kitchen. I don't have all four walls keeping the air contained in the kitchen. And part of the trigger sheet, this is brand new to the trigger sheet we have at Energy Code ACE, we added a table about when you've triggered the ventilation mandatory requirements as is dictated by ASHRAE 62.2. So we're going to start with the, hey, I'm remodeling a kitchen or a bathroom. So you'll see here remodeling a bathroom, yes, you now need to show compliance to bathroom local exhaust. You're remodeling the kitchen. Yes, you need to consider what's going on for kitchen local exhaust, and we'll talk about some of the subtleties of when you're using the kitchen hood as your local exhaust system, and that when you're adding a dwelling unit to an existing home or you have a new dwelling unit that's being added to the home, you will need to consider the indoor air quality and local exhaust requirements of ASHRAE 62.2. When we talk about local exhaust, we have two ways we can go. We can do demand controlled or continuous. Demand controlled is that homeowner has that ability to be sitting there and turning that system off, and it wasn't designed to stay on all day long. Continuous, well, the homeowner still has the ability to turn that system off, but it's been designed to run continuously. And how the heck is the homeowner supposed to know what's going on in terms of the design of their system? Bruce?
Well, hopefully the installing contractor has created some documentation and labeling regarding that indoor air quality system and explains to them how it works. For instance, I know up by you and definitely down by me, our air quality is not good outside right now due to the fires.
It's so scary looking. It's so scary looking out there today.
So we want to make sure they understand that if that fan is on, and depending on the system, whether it's a supply, exhaust, or a balanced system, that they understand what it is and whether they should turn it on, leave it on, or shut it off in the event of something like contaminated air outside. And they say, of course, in here, unless that function is obvious, such as your toilet fan, but really, even if it's your bathroom fan, that's most commonly where the contractors put the continuously running whole house indoor air quality fan, that should definitely be labeled that it is for indoor air quality, that it's not just a standard bathroom fan.
Because ASHRAE 62.2 requires there be a manual on-off switch, always. I don't care if your system is continuous. I don't care if it's been designed to be demand controlled. We want to make sure that that homeowner has the ability to turn the system off when there's days like we've been having here in California recently, in which bringing in outside air is not something that is healthier than just keeping the air in the home and just keep refiltering it with our recirculation system. So demand controlled, we have the ability for demand controlled system to be a vented range hood or any other exhaust fan in the kitchen. For non-enclosed kitchens, we have a slightly different formula that Bruce was saying. We have different formulas we're using to try and determine our airflow to get the air changes that we want. And for our bathrooms, well, we just need that 50 CFM for our bathrooms. We're really not even caring whether they're humongous or not. Using the continuous system, well, then our formulas change to reflect the fact that we need to figure out the air changes per hour. We want at least 5 of them per hour for our kitchen. And that bathroom gets to go down to 20 CFM. So Bruce and I have definitely seen where we see the lovely recirculating charcoal kitchen hood. Bruce, what does that mean to their local exhaust requirements?
It means they must have some central system in the kitchen typically that's you're basing their air changes per hour on that kitchen volume instead of just a range hood that is certified through HVI to move at least 100 CFM and be less than 3 zones of noise.
So they've definitely then signed up for another mechanical exhaust system to be installed in that kitchen if they're not using a vented kitchen hood. And Bruce already kind of gave us a little hint of what also needs to happen when it's a vented kitchen hood. What has to happen with, and what is our HERS rater doing with these hoods?
Well, because kitchens are unique to most buildings, they're not common as far as the kitchen hood dimension sizes. And to be able to measure the airflow through there, you're going to need a hood that can actually match right up to the exhaust hood. They're not required to be physically measured. What's required is that the manufacturer has to list their hood with either HVI or AHAM. So then there's going to be a certification number issued to that manufacturer. It's going to go on that hood. What has to happen is the HERS rater has to find that certification number and look up the listing and verify that the hood is listed. What that listing is certifying is that when the fan is properly installed, it will move at least 100 CFM and that the sound rating will be less than 3 zones. It's very important, the sound rating, that one of the biggest things they find in ASHRAE when they do the studies on occupants, the biggest reason they turn the fans off is because they're too loud, that they don't want to turn the radio up louder, that it's hard to have conversations. So verifying that it's properly listed and properly installed, that it will move that much air and have a sound rating less than 3 zones.
I have to tell you, honestly, I just got out of a rental in which the exhaust fan, the entire house shook when you put that kitchen hood on. And only because I know how important it is, I still would sit there and put that sucker on, but as soon as I didn't need it anymore. Let me tell you, I turned it off. I do live in a place now that has a nice, quiet kitchen hood, and I have it on a lot. Clothes dryers. Clothes dryers, honestly, when we have one, we want to make sure it exhausts to the outside. The only exception being condensing dryers plumb to a drain. There was a while there that was kind of popular. I haven't seen it as much anymore. Bruce, are you seeing those where we are not exhausting to the outdoors? Like some apartment buildings, I saw them for a while, but they don't seem to be popular anymore.
Yeah, I was going to say the only place that I've seen them was a retrofitted hotel to multifamily to where they were putting them in a closet, so there was no way to vent them to the outside, so that's exactly what they did. They did condensing units to a plumbing drain.
And what else do we want to make sure everyone walks away from in terms of what is so important to energy efficiency when we're talking about clothes dryer location?
Well, the condenser airflow is just as important as the evaporator airflow on the inside, and it's a mandatory requirement that the outlet for a dryer is located a minimum of 5 feet away from the condenser location. I've seen where the dryer outlet is directly behind the condenser, and the back coil of it is just basically, it looks like paper mache from all the lint and everything stuck to it, because the coil gets wet in the summertime. The lint is blowing out of the dryer, and it really impacts the efficiency of that air conditioning unit when it can't get the proper airflow because it's impacted by dryer lint. So minimum 5-foot clearance between the dryer outlet and where the condenser is going to be located.
Let's now transition to the conversation about whole house mechanical ventilation. This is not the same as a whole house fan. This is, I'm considering how am I bringing in fresh, beautiful outside air for maintaining indoor air quality. This is required for new homes. This is required for additions when they exceed 1,000 square feet. And this is required anytime I'm adding a dwelling unit to an existing home, whether that's within the conditioned space or I'm adding on with an addition for the ADU. I don't care if it's only 200 square feet. I do trigger these requirements. So ASHRAE 62.2 has a whole section. They call it dwelling unit ventilation, which I think makes sense, whereas our energy code calls it whole building, IAQ, which gets so messed up with whole house fan. It drives me crazy. But we're talking about how the entire living space is being ventilated, not just the kitchen, not just the bathroom, not just talking about the clothes dryer. And again, our trigger sheet does speak to when we need to be concerned about not only meeting our local exhaust requirements, but our whole building indoor air quality requirements. The formula for this takes into account the entire square footage of the home and number of bedrooms, because number of bedrooms, the code kind of uses that to kind of determine how many people might be living in this home. And this formula changed, didn't it, Bruce?
Yeah, it's a small change from the previous code because actually California had its own version of ASHRAE 622-2010 that we've been on, and ASHRAE went to 622-2013. We just kind of ignored that and stayed on 2010. And with this code cycle, we're jumping up to the most current version of ASHRAE, which is ASHRAE 622-2016. So what we have is just a little bit of a different modifier there for the multiplier against floor area, and then 7.5 times the number of bedrooms plus 1. So we can see for 2,000 square foot, 3-bedroom home, we end up with about 90 CFM is the required ventilation. If we did that with the 2016 formula, we would have been down to about 50 CFM. So that is the straight required minimum ventilation rate without taking into account building envelope leakage or anything else.
Now remember, we talked previously about how ASHRAE 62.2 requires the minimum CFM for a bathroom fan, local exhaust, to be 50. Now we can use that bathroom fan as our whole building ventilation system as long as we jump through a couple of hoops. But remember now, these numbers have gotten a lot bigger. So it might have to be more than one bathroom fan that's going to be utilized for the whole building ventilation. Now, we do have requirements regarding how loud these fans can be. So if it's going to be the dwelling unit ventilation, The zone needs to go down to 1 because we want it on a lot more often. We want to make sure it's staying on. If it's a local exhaust demand controlled, which is what we typically see, this is what people are putting in there, that's when we have the 3 zone requirement that Bruce was talking about for that kitchen hood. But it needs to go all the way down to 1 zone regarding what's going on in terms of how noisy is it. So Jorge, yeah, converting a garage to a dwelling unit is considered an addition. But one of the things they changed in the 2019 code cycle is they said we don't care what the square footage is associated with a new dwelling unit. You are going to make sure it has whole building indoor air quality systems in play. Previously, it was only if that addition was over 1,000 square feet. This code cycle says any new dwelling units, I don't care the square footage. So because it's an ADU, the whole building ventilation is required. If it was using the garage, converting it to a living room, yeah, you probably didn't trigger the whole building ventilation requirements. But because Enrico is, oh gosh, I might have said that wrong. I'm so horrible at names. Because it was an ADU, that's when we're saying yes, it did trigger the whole house ventilation requirements. And here's a list of the different types of systems I can utilize. I can do a supply-only system. Then I have a tendency to overpressurize the home, and what's the scariness with that, Bruce?
Turning, if you have like an atmospheric water heater or something like that, into a turbocharged water heater. It's basically like turning on an afterburner, feeding it air.
Had an exhaust-only system. I'm going to...
Oh, I'm sorry, exhaust only. You could suck it back in, yes.
Yeah, well, you were describing supply. Now I just went to exhaust. So I have to tell you, I honestly don't love at all a supply-only system, an exhaust-only system, because there's inherent issues with them. I like a balanced system, but that means I have 2 fans. I have a fan that is supplying a certain amount of CFM, of which the exhaust fan system paired for this system is equal or maybe a little bit greater than what's going on with supply. But then I open up the door to be able to use energy recovery or heat recovery equipment that's sucking out any of that heat or cooling energy that I'm spending money to make my home more comfortable, and I'm utilizing that. And our central ventilation systems. Central ventilation systems, if I am using the continuous system, I'm not allowed to use that central air handling unit, because that's a big fan that I don't want to have on all the time, though I can use it for my intermittent systems. So there's different choices, things to be aware of, and that's what that CF2R really is all about, is having the contractor document what method did they use to meet their indoor air quality requirements. Let's do a check your understanding. What is the local exhaust requirement when you're remodeling a bathroom? Excellent. I started off easy for you guys. Okay, next question. What is the local exhaust requirement for this kitchen when using a recirculating, non-vented kitchen hood? Okay, you guys aren't as confident with yourselves with this one. Because I am not using a vented kitchen hood, the HERS verified kitchen hood is not in play because it's not exhausting to the outdoors. What needs to happen is I must have kitchen local exhaust in addition to this non-vented kitchen hood to meet the local exhaust requirements